Hi everyone. Let's discuss in further detail the rational zero test or the rational roots theorem. Remember that the template for the list of possible rational zeros, the list of candidates, is given by plus or minus factors of the constant term over factors of the leading coefficient. Now, 4 questions for you. 4 questions. First of all, what is the most common error when getting the list of candidates? The most common student error. This is more of a student question than a math question. Second, if a candidate works as a zero in the synthetic division, can it work again? So if a number works in the dunk tank and you get a remainder of 0, can it work again when you get the corresponding quotient? If a candidate does not work as a 0, can it ever work down the line for one of these quotients down here? Number 4, does the theorem apply to f of x, where f of x is x squared minus 3? So consider these 4 questions regarding the rational zero test or rational roots theorem. I'll give you a minute. All right, what's the most common student error when getting the list of candidates? It's that students take the reciprocal. They switch or flip the fraction around. The problem is that students often do this. Don't do that. Don't switch. Don't try to take reciprocals. Now, one way to remember which way it goes is to use a simple example, such as x minus 2. Remember that if you have x minus 2, there's an implied 1 out in front. So what will be the list of candidates? Now, some students might think, oh, is it the coefficients, is it the factors of 1 over the factors of negative 2? Does it go plus or minus 1 over plus or minus 1 or plus or minus 2? Or could it be the factors of negative 2 over the factors of 1? Plus or minus 2 plus or minus 1 over plus or minus 1. Well, here's the deal. What is the only rational zero of x minus 2? The only rational zero is given by 2. Well, how can we get 2? Can we get a 2 from here? Nope. You can't get a 2 from here. You can only get a 2 from here. So it better be factors of negative 2 over factors of 1 and not vice versa. So just like with factoring and long division, think about a basic example. And that'll help you remember to not switch these, to not take the reciprocals. Again, that's the most common student error. If a candidate for a rational zero in the synthetic division works, can it work again? And the answer to that is yes. The answer to 2 is yes. Here's an example. Well, imagine a polynomial that factors as x minus 2 all to the 10th. Well, guess what? If you take this guy, if you put 2 in the dunk tank, you're going to get 0 as the remainder, so it works out. and you get the quotient here. You have x minus 2 times this quotient over here. This quotient over here will be the equivalent of x minus 2 all to the 9th. And in fact, if you keep going, it turns out that you can put 2 in the dunk tank 10 times and it'll work out. You'll get a 0 remainder. If you don't believe me, take something like this. Take something like x squared minus 4x plus 4. That's a PST. I hope you recognize that as the square of x minus 2. Apply synthetic division with k equals 2. Do it twice, see what happens. This is just the extension of that. Third, if a candidate does not work as a 0, can it ever work? The answer to that is no. Imagine a polynomial up here, and 2 is not a 0. 2 is not a 0. Let's say it's a polynomial in x. That means that x minus 2 is not a factor. Well, imagine factoring this thing further over the reals. That times that, and then this may factor as that times that, and so forth. Well, here's the thing. If x minus 2 is not a factor of the big guy, it's not going to be a factor of any of these smaller guys, these lesser degree guys down here. So if 2 is not a 0 up here, x minus 2 is not a factor up here, and therefore 2 is not a 0 down here, anywhere. X minus 2 is not a factor for any of these guys down here either. 4. Does the theorem apply to x squared minus 3? Actually, the answer is yes, but. Yes, it's of the right form, right? We have a polynomial in descending powers, integer coefficients. So the theorem applies. But what the theorem says is the following. It says if this has rational zeros, they have to be in this list. So it would have to be in the list plus or minus 1 or plus or minus 3. Remember, it's got to be plus or minus factors of the negative 3 over factors of the 1 over here. So if this thing has rational zeros, it's got to be either 1, negative 1, 3, or negative 3. Well, none of them work. The only zeros for this thing, the only zeros for f are root 3 and negative root 3, which are not rational. So here's the thing. The theorem applies. It's true that if it has rational zeros, it's in this list, but this thing has no rational zeros. So none of the numbers in this list worked. All right. So the theorem applies. It's just that none of the zeros were rational. So it didn't help us any in terms of cracking this thing. All right. Next up, we're going to talk more about factoring.